Introduction to Java Methods. Welcome everyone. Today we are diving into the core of Java programming by discussing methods. Think of methods as the building blocks that bring structure and action to your code. What is a method? So what exactly is a method? Simply put, it is a block of code designed to perform a specific task. By using methods, we make our programs more organized, easier to understand, and, most importantly, reusable. Why use methods? Why do we bother with them? First is the dry principle: don't repeat yourself. Methods allow for code reusability. Write it once, use it many times. They also improve organization by breaking complex problems into manageable chunks. This leads to better maintainability. If there's a bug, you fix it in one place rather than searching through your entire program. Plus, it makes debugging much easier and improves overall readability. Anatomy of a method. Let's look at the components that make up a method. Access modifier. This defines visibility, like public or private. Return type, the type of data the method gives back, such as an integer or a string. If it returns nothing, we use void. Method name, a unique identifier, usually a verb in camel case. Parameter list, these are optional variables passed into the method. Method body, the actual code contained within the curly braces. Types of methods. Java offers several types of methods for different needs. Predefined, these are built-in methods like math.squareRoot. User-defined, these are created by you, the programmer. Static versus instance, static methods belong to the class and don't need an object to run, whereas instance methods require an object. Parameterized, methods that accept inputs to work with different values. Overloaded, methods with the same name but different parameters. Recursive, methods that call themselves to solve subproblems. How methods work. A method has a signature, a return type, a name, parameters, and a body, and is called to execute. In code, a signature like integer add, integer A, integer B, defines how we interact, and return statement returns the result back. Real-life example. Think of a method like a machine. You provide an input, it performs a process, and it delivers an output. A classic example is a calculator's add button. Basic method syntax. The basic syntax follows the pattern: return type, method name, and parameters which are enclosed in parentheses. Calling a method. For example, to call a simple method like say hello, you just write the name followed by parentheses. This executes the code inside, and in this case, prints hello world. Methods with parameters. To make methods more flexible, we use parameters. If we define a method, greet with a parameter string name, we can pass in a specific value, like David. The method then processes that specific input to output hello David. Method with return value and void. Methods can also return data back to the caller. If we use integer variable result is equal to add 5 and 3, the method calculates the sum and returns 8 to be stored in our variable. Remember, void methods perform an action but return nothing, while non-void methods must return a value that matches the declared return type. Return type explained. These are the common return type: integer, double, string, boolean, and void, which does not return any value. Void methods. Void methods do not return a value. They perform an action only. Non-void methods. Non-void methods must return a value. Return type must match the value returned. Static methods. Static methods are unique because they belong to the class itself. You don't need to create an object to use them. For instance, a static integer square, int x, method can be called directly as square 7 to return 49. Recursive methods. Recursion is when a method calls itself. This is ideal for repetitive problems like factorials. However, it must have a base condition to stop, or you'll end up with infinite calls. Method overloading. Overloading allows you to use the same method name for different tasks by changing the parameters. For example, you could have one add method for integers and another for doubles. Java is smart enough to know which one to use based on the input you provide. Access modifiers. You can control access using public, private, or protected. Best practices. Some of the best practices while programming, which saves the programmer from his own code. Use meaningful method names. Keep methods short. One task per method. Keep methods short and focused. Use meaningful identifier or variable names. Avoid too many parameters. Document behavior with comments. Common mistakes. Watch out for common pitfalls like forgetting your return statement or using the wrong return type or not calling the method. Summary. In summary, methods are essential for memory efficiency and high-level logic. They encapsulate logic into reusable blocks that make your Java programs cleaner and more professional. They improve structure, reuse, and clarity. They improve code structure and readability. Java supports various method types for flexibility. The dry principle: don't repeat yourself. Memory efficiency: code is loaded into memory once. Readability: high-level logic is easier to follow when details are hidden in methods.